Uranus is one of the most unique planets in our solar system because it does something that no other planet does. It rolls on its side. Most planets spin like a top, with their poles pointing up and down, but Uranus is tilted over so far that it spins more like a ball rolling on the ground. This strange tilt of about 98 degrees makes Uranus look like it's lying sideways in space, and it's been puzzling scientists for a long time. So, how did this happen? What could cause such a massive planet to lean so far over? To answer that question, we need to take a journey back in time to the early days of our solar system. But first, let's understand what we mean by a planet's tilt and why it's important. What is a planet's tilt? All planets spin or rotate around an imaginary line called an axis. Think of a spinning top. The stick of the top is its axis, and the direction it points in is the tilt. Earth, for example, has a tilt of about 23.5 degrees. This tilt is why we have seasons. When one part of Earth is tilted toward the sun, it's summer, and when it's tilted away, it's winter. Now, Uranus is different. Its tilt is so extreme that its axis points almost directly at the sun. This means that for a quarter of Uranus's 84-year-long orbit around the sun, one of its poles is in constant sunlight, while the other is in total darkness. Imagine living on a planet where one half of the year was all day and the other half was all night. But how did Uranus end up this way? The giant impact theory. Scientists believe that something really big and dramatic happened to Uranus billions of years ago. The most widely accepted idea is called the giant impact theory. This theory suggests that in the early days of the solar system, when everything was still forming and planets were growing, Uranus had a massive collision with another huge object. This object might have been a giant asteroid or even another planet, possibly as large as Earth. Imagine two giant balls in space crashing into each other. One of them is Uranus, and the other is this mysterious object. The impact was so powerful that it knocked Uranus over, causing it to tilt onto its side. But this wasn't just a little nudge. It was a major crash that changed the entire way Uranus spins. The force of the impact likely sent shock waves through the planet, affecting its core and outer layers. It could have also thrown debris into space, some of which may have even formed some of Uranus's moons or its rings. This kind of impact would explain why Uranus spins sideways while the rest of the planets in our solar system don't. Was it just one impact? While the giant impact theory is the most popular explanation, some scientists think that more than one impact could have caused Uranus's tilt. They believe that maybe it wasn't just one big crash, but a series of smaller hits over time. These smaller impacts could have gradually tipped Uranus over bit by bit instead of one giant smash. Imagine playing with building blocks and lightly tapping one until it eventually falls over. In this case, each tap would be a collision with a smaller object. Over time, these collisions could have added up to make Uranus lie on its side. Other theories. Could the moons be involved? While the giant impact theory is the leading explanation, some scientists have explored other possibilities. One of these involves Uranus's moons. Uranus has 27 known moons, and they all orbit the planet in the same tilted direction. Some scientists suggest that the gravitational pull of these moons, combined with the planet's rings, could have played a role in tipping Uranus over. In this idea, the moons might have slowly shifted Uranus's axis over time through their gravitational forces. While this theory isn't as widely accepted as the giant impact theory, it's still interesting to think about how a planet's moons could affect its tilt. What about the rings? Like Saturn, Uranus has rings, though they are much fainter and harder to see. These rings are made up of tiny particles of ice and rock. Some scientists wonder if the formation of these rings might be connected to Uranus's tilt. If the rings formed after the planet was tilted, they could have been created by debris from the giant impact. Alternatively, if the rings were there before the tilt, they could have been involved in the process that caused Uranus to tip over. What makes Uranus's tilt special? Uranus's tilt makes it very different from other planets, not just in how it spins, but also in how it experiences seasons. Remember how we talked about Earth having seasons because of its 23.5-degree tilt? Well, Uranus's 98-degree tilt creates the most extreme seasons of any planet in the solar system. Because of the tilt, One of Uranus's poles points directly at the Sun during its long orbit. This means that for about 21 Earth years, one pole is in constant sunlight while the other is in darkness. Then, as Uranus continues its orbit, the situation flips and the opposite pole gets all the sunlight. This leads to 21-year-long winters and summers at each pole. The mysterious core of Uranus. The tilt of Uranus is also connected to its core. The giant impact that knocked the planet over likely affected what's inside the planet too. Uranus's core is different from other gas giants like Jupiter and Saturn. While those planets have very large, dense cores, Uranus's core is much smaller and less defined. This could be because the impact disrupted the way the planet formed, mixing up the materials inside, and preventing the core from developing the way it normally would in a planet of Uranus's size. How does the tilt affect Uranus's weather? Uranus is known for having some of the coldest temperatures in the solar system. Even though it's not the farthest planet from the Sun, that's Neptune, Uranus still reaches incredibly cold temperatures of around -224 degrees Celsius, -371 degrees Fahrenheit. This is partly because of its distance from the Sun, but its extreme tilt also plays a role. The long periods of darkness at one pole and constant sunlight at the other create strange weather patterns. When the seasons change and the poles swap their sunlight and darkness, massive storms can form in Uranus's atmosphere. These storms, along with strong winds, are influenced by the planet's unique tilt. Could a giant impact happen again? The early solar system was a chaotic place. Planets were still forming, and there were lots of leftover rocks and debris floating around. Collisions between planets and other large objects were much more common back then. Today, the solar system is a lot quieter, and the chances of a giant impact happening to a planet like Uranus are much lower. However, studying Uranus's tilt helps scientists understand what the solar system was like in its early days. It also gives them clues about how other planets might have formed and changed over time. By learning more about Uranus, scientists can also better understand exoplanets, planets outside our solar system that might have experienced similar impacts. Why is Uranus so fascinating? Uranus's tilt makes it one of the most intriguing planets in the solar system. Its sideways spin, long seasons, and strange weather all make it stand out. Understanding what caused its tilt helps scientists piece together the history of our solar system and offers clues about how planets can change. The idea that a giant impact could tip over a planet as massive as Uranus is mind-blowing. It shows just how powerful collisions in space can be and reminds us that the planets we see today have gone through many changes over billions of years. In the end, Uranus's tilt is a cosmic mystery that scientists are still unraveling. While the giant impact theory is the leading explanation, there's always more to discover about the icy planet that spins on its side. And who knows, future missions to Uranus might uncover even more secrets about its wild and wonderful tilt.